So for question 1, and this is on page 42, they say tugboat is capable of pulling a ship with a force of 100 kilonewtons. Okay, so it means 100,000 newtons. If two such tugs are pulling on one ship, they can produce any form of force ranging from a minimum of 0 newtons to a maximum of 200 kilonewtons. Give a detailed explanation of this, how this is possible. Use free body diagrams to support your explanation. Now, first of all, to get a net force of 0 newtons, how do these two tugboats need to pull on a boat? Well, it's quite easy. They just need to pull in opposite directions. So if the tugboat 1 is pulling in that direction and tugboat 2 is pulling in that direction, and they both pulling with a force of 100 kilonewtons, then it means that your net force would be 0. So that's the first answer. For a net force of 200 kilonewtons, how do they need to pull? They need to pull in exactly the same direction. So if this is my free body diagram, both of the tugboats I would want to pull in exactly the same direction with their force of 100 kilonewtons. So if those are my diagrams, then just add the forces over there. So it will be 100 kilonewtons, both of them in the same direction. So that's question 1. If we move on to the next question, question 2, they say a 12 kilogram box is placed on a rough surface. A force of 20 newtons applied at an angle of 30 degrees to the horizontal cannot move the box. Calculate the magnitude of the normal and friction forces. Okay, so if we draw an image of this situation, we've got a box over here that's on a surface, and we've got a force acting at an angle of 30 degrees. Okay, so there's our force. And this force has a magnitude of 20 newtons. Now, if this box is not moving, what type of friction do I have? I've got static friction. So to calculate the static frictional force, what do we need? We need the coefficient of static friction, and we would need the normal force. Now, in this case, we are not given the coefficient of static friction. So we need to find another way to do this problem. Now, let's draw a free body diagram of this situation. So in this case, we would have the normal force acting straight up. So that would be our normal force. We would have the weight acting straight down. Then we've got our applied force acting at an angle. Okay, so there's our applied force. So, and then because of the applied force in that direction, we will have a frictional force opposing the horizontal component of the applied force. So this would be our free body diagram. And I just want to label it because remember, all free body diagrams have to be labeled. So normal force, weight, frictional force, static, and then our applied force. Okay, so those are the forces acting on this box. Now, what force is resisting this, or the frictional force is resisting which force? It's resisting the x component of this force. So there's an x component of this force that the frictional force is resisting. And if this box is not moving, it must mean that the frictional force and that x component have the same magnitude. So in other words, if we go to calculate the frictional force, our frictional force will be equal to the x component of the applied force. Okay, so calculating that, if it's 20 newtons, the x we will use cos. So 20 cos 30 will give the value of that one. So 20 cos 30 gives a value of 17.32 newtons. This would be, and they say to the magnitude, so we don't need to add a direction, so that's fine. Okay, and the normal force in this case, be careful now, the normal force won't be equal to the weight because this force over here has a y component that's acting up. So in other words, your y component of this force plus your normal force would be the balance of your gravitational force. So your equation for calculating the normal force in this case would be the normal force is the gravitational force minus the y component of the applied force. So if we have a 12 kg block, the weight is 12 times 9.8 minus the y component is 20 sine 30 degrees. And that then 12 times 9.8 minus 20 sine 30 gives a value of 107.6 newtons. So that's your normal force and your frictional forces magnitude. So this is the first video. I will make more for the rest of them.